Hey everyone! I've been hearing that building smart contracts with Rust is all the hype right now. And what if I told you guys that on Cartesi you've been able to do it for, well, quite some long time now? Just so you can have an idea of how it works, I'm gonna show it real quick, right? First thing we gotta do is Cartesi create, Rust example, and select the template Rust, okay? This will use our CLI to create our own first Rust Dapps. Now that we have our app created here, let's implement some logic for a Hello World application that will allow us to return the same input values that we sent for this application. All right, so let's build. Remember to save your project and have your Docker desktop running. Seems like it was built successfully. Now let's use the command Cartesi run to run it. The run is successful, so my application is running. And to interact with it, I'm actually gonna use my browser, entering this exact endpoint right here, localhost 8080 Explorer, okay? Here I can actually check my transactions and even send transactions to my application. I know that this is the ID of my application on my local test network. So just for good practice here, I'm gonna clear the activity data tab and send an input. This input has to be on hex format, right? So let's just go to hex to string and say, hi, I'm John. Once I sign this transaction, what actually happens is the transaction data is sent to a smart contract hosted in the underlying blockchain called input box. Whatever was sent to the input box is going to be found right here inside payload, inside data in the request element. What I'm doing is getting this payload and actually creating a response with the same content. So I can go to my inputs, check the input, and I'm also able to check it as a text. I sent this input, and as an output, I generated this notice right here saying the same thing. This is what we call an echo dep. Now, let's go for something a little more complex, okay? Let's create a Counter Dapp. I know for my Counter Dapp, I'm gonna have some requirements, right? First thing, I'm gonna have to actually change my cargo.toml here and add some dependencies. Remember to save it. And now for the code. And now, after our code is built, just like before, we're gonna have to run Cartesi build and then Cartesi run. We're gonna head to the Explorer to test it. And now if we refresh, there are no inputs because we restarted our application. So let's add some inputs, right? I'm gonna add a raw input to this application. And the content, well, for that, let's give a check on the logic we implemented, right? First thing we do is we decode the input that was sent. And after decoding it, we check it against the string. If I send add or the plus sign, I will add 1 to the number counter. If I send subtract or the minus sign, I will subtract 1. Anything else, I'm gonna print unsupported operation. After that, it's just basically the same. I'm just creating a new map. It's a JSON. I'm formatting it to Ethereum hex and sending it back as a response. Let's try both ways, shall we? Now, going to my inputs, I can actually check the first input was add, and the notice created was operation add value 1. And the second one, I sent the plus sign, operation add value 2. So if I keep adding, the value will keep increasing. What if I subtract them? After subtracting it, my value is back to 1. But what if there was another way of checking this value? What if I didn't want to go to the transaction histories and check the value itself? What if I could just inspect the state of my machine, right? Well, that's why I implemented this second part here. The handle inspect are basically functions that you go directly to the node and you check the state of the machine without having to go through transactions. This is really helpful. So the logic I implemented here is I decode the input, I break it down into params, I compare it to the value counter to see if that's the request that's being called. I get the value of the variable, I serialize it into a response object, right? And I send this response object as a report. How can I use this though? Well, good question. Right here, when my application is running, I also get this guy, which is an inspect route. But this inspect route default is not implemented. The one we implemented is called counter. So it's inspect/counter. And now if I get this payload and I go to a hex to string converter, I'm gonna get the current value that's in the counter. This way you can see how you can implement functions akin to post with handle advance and getters with handle inspects. Now, at last, but not least, I do have one last thing I want to show you. This right here is another smart contract on Cartesi, but this has some intricacies that make it very special, right? First thing is I actually implemented this function called mint token. As you can see, we do need some other dependencies, but the important thing is that I created this function right here called mint token, and it generates a voucher. This voucher receives as a payload this Ethereum hex right here, which is created from this object, mint payload. What we're doing is defining the mint function according to the ABI of our ERC721 contract. Now, I already know that the contract will be deployed to this address after I build and run the solution. I can run a Cartesi build and run it with Cartesi run. But this time, I'm gonna be using the flag epoch duration. And I'm gonna setting the value to 10. This means that I will need to wait 10 seconds before actually executing my voucher. All right, so our application is running. So now that our app is running, I'm gonna deploy this guy right here. It's basically an ERC721 with a mint function. All right, now my contract is deployed. I can see its functions, and it's probably running as expected in my local host. So let's go to the Explorer. And just by checking my handle advance right here, what I do is I expect the mint function to be called. And if it's called, I'm gonna call the mint function. And after that, I'm gonna create a notice saying that the mint function was called as well. Here is the hex code for the word mint. All right, so if I go into inputs, refresh and open it, you can see that this voucher was generated right here. As 10 seconds pass it, I can actually execute the voucher. This is basically a pre-signed function, right? This was my input, mint. This is the notice generated, and this is the voucher generated. So once I execute the voucher, what's gonna happen is the transaction will be completed and my NFT will be minted. All right. So this is a confirmation. I can go here on my NFTs, import an NFT. And if we go to my smart contract again, this was the address of the smart contract, right? And I minted the NFT of ID 3. So let's just set here, entry, import, and hey, here's my NFT. It worked fine. All right, I hope you enjoyed, and thank you for your attention. Now, it's time to start building your dApps on Rust. Bye!